So same thing here. We need to be able to put this into have the base argument and exponent. Well, this one has all the parts already there. My base is 2x, my exponent is z, and my argument is 4a squared. Now there's something wrong with this because the exponent is not on 2x, it's just on the x. I have to be clear, this is my base. I have to have that exponent on that whole base. So I have to put that into brackets. And I'm actually going to leave that in, I'm going to do that in red, okay, because this is important. This is something that is often missed when you do this. Okay, so if this was an equation, I could ask you now to solve for x. Okay, I can get you to solve for x for this problem if I wanted to, or solve for a or something like that. Okay, this question we really just trying to put things into work on the definition of log and understand how to algebraically manipulate exponents and logs. So this part here, our calculator has base 10 and base e built into it. We haven't really talked about base e yet, but it has base 10 and base e in it. So if we want to use our calculator for other bases, for example, base 3 or base 59 or something like that, we need to change the base. And we can do that to accommodate any base we want. So we use something called the change of base formula. I'm not going to justify this formula right now. I'll show you how we can justify it later, but I just want you to know the formula. And we can change the base by doing this. I can change this log base a into any base. X could be base 10, and normally if you're using your calculator we'd use base 10, but I can change it to any base, okay, by just taking this, just the left side. Okay, so this is my exponent still, that c represents my exponent, it doesn't change. So I'm not going to change the exponential expression, but I can give an equivalent expression using a different base by doing log base of whatever I want, in this case maybe 10 of the argument, divided by log base 10 of the base. Okay? And that will give me an equivalent expression that calculates the exponent c. Now, like I said, I'm not going to justify this, and really this is the only place we really see dividing of logs. Okay, this dividing of logs, only time you really see dividing logs is in this change of base situation. So this is a common problem that I see. You know, let's go base 2 or something like that, of a minus log base 2 of b. Oh, subtract means I divide the logs. So I go 2 and I divide. Okay, this is not the case. Some people learn this rule. There's a rule we're going to learn. And some people say, oh, minus means divide, so they divide logs. No, well, minus means minus, divide means divide. We cannot just all of a sudden say that minus and divide are the same thing. Okay, so that's a problem that I see. So if you're going to divide logs, right, be very careful, because this is the only place we really are going to see dividing of logs is when we use this change of base form.